Ever wonder what actually happens when you tap a button on your favorite app? I mean, what's really going on behind the scenes? Well, today, we're going to peel back that curtain and explore the hidden digital city that powers pretty much everything you use every day.
So here's our roadmap. We'll start with the giant puzzle that developers are trying to solve. Then we'll walk through this city of services, see how a digital directory keeps it from getting lost, check out the blueprints used to build it all, and finally look at the real cost of all this amazing power.
All right, so let's start with the core problem. The apps we use today, they're not just simple little programs anymore. They are unbelievably complex ecosystems, right? With just a ton of moving parts that all have to talk to each other and work together perfectly all the time.
And that, right there, is the billion-dollar question. How do you stop one tiny bug in one small feature from bringing the entire system crashing down? Seriously, this challenge forced a complete revolution in how we think about and build software.
So, the first piece of the puzzle was to stop trying to cram everything onto one giant, super powerful computer. Instead, the whole industry shifted to what we call distributed systems. The big idea is to just spread the work out across a whole network of computers. It makes everything way more resilient and easier to scale up. Okay, so spreading the work out is a great first step, but that's really only half the battle. Now you've got a new problem. How do you organize all that work so it doesn't just turn into absolute chaos? Well, the answer is a classic strategy: divide and conquer. Instead of building one massive, clunky program, what engineers call a monolith, developers now build dozens, sometimes even hundreds, of tiny, super-focused applications. We call them microservices. Each one does one thing and one thing only, and it can be worked on or scaled up all by itself.
And this is where that whole digital city metaphor really starts to click. Let's say you buy something online. Your request doesn't just go to one place, no way. It's like it takes a little trip through the city. First, it stops at the authentication shop to prove who you are, then swings by the inventory office to see if the item's in stock, and finally, it hits the payment bank to handle the money.
Now this is awesome, right? It's super powerful, but it creates a brand new and absolutely massive problem. If these little services are constantly popping up, getting updated, or moving around, how in the world does the payment service know where to find the inventory service? You can't just have a static address book. It'd be out of date in seconds. You need a live, dynamic map. So how do we solve that navigation nightmare? Well, the solution is pretty elegant, actually. It's our city's digital directory. This is the key to keeping everything connected when the environment is always changing. The technical name for this is Service Discovery, and honestly, it's kind of the magic that makes this whole digital city work. It's what allows all these little services to find each other on the fly, making sure that when you ask for something, your request goes to a service that's actually up and running. Right at the heart of this whole system is something called a service registry. The easiest way to think about it is like the city's official business directory, or maybe even better, it's Google Maps. When a new service, a new shop, let's say, opens for business, it adds its address to this central directory. And if it closes down or crashes, poof, its listing gets removed automatically. Now this is where it gets pretty cool, because there are two main ways this directory can be used. With client-side discovery, it's like you look up the address for a pizza place and then drive there yourself. But with server-side discovery, it's more like you call a central delivery service and they figure out which pizza place is open and closest to you, and then they send a driver to get your food. And that second one, the server-side approach, is by far the most common. The original service just needs to know one address, the address of the central dispatcher, which we call a load balancer. That dispatcher acts like a traffic cop. It checks the directory, finds an open service, and sends the request on its way. The original client is totally clueless about all that complexity, which is exactly what you want. Okay, so we've got our city plan and we've got our digital map. But with potentially hundreds of these little shops and offices to build, how do you do it fast? And how do you make sure they're all built consistently instead of each one being a unique, handcrafted headache? The answer is you use frameworks. You can honestly think of them like prefabricated construction kits for developers. They come with all the essential stuff like the plumbing for communication and the electrical wiring for security already built in right out of the box. And here are just a few of the most popular kits on the market today. You've got heavy hitters like Spring Boot in the Java world, or Express.js for anyone using Node.js, Django for Python developers. The point is, these kits are battle-tested and give teams a massive head start when they're building out their part of the digital city. But here's the really critical insight.
The smartest organizations don't just use these kits off the shelf. No, they customize them to create their own master architectural blueprint for all of their services. And this incredibly powerful idea is called the Service Template Pattern.
And the benefits of doing this are just enormous. You're not building every shop from scratch. You start with a standard blueprint. This means developers can jump right in and focus on what makes their service unique, the actual business logic, instead of wasting weeks reinventing the wheel on stuff like logging and security every single time. It's just faster, more consistent, and way more reliable.
Now, this architecture is unbelievably powerful. It's what enables the massive scale of the internet as we know it. But, and you knew there was a but coming, all of this complexity and constant change introduces its own set of pretty significant challenges.
I mean, think about it. The entire digital city relies on that central directory. If the service registry goes down, nobody can find anybody else. The whole system just grinds to a halt. It's a massive single point of failure. This is exactly why companies like Netflix actually built their own super robust registry and why others rely on bulletproof tools to make sure this one critical piece of infrastructure is always fast, always accurate, and never ever goes down.
So yeah, it's a huge challenge. But at the end of the day, this model is what makes the modern, scalable internet possible. Service discovery is the invisible nervous system that allows apps like Netflix, Amazon, and Google to operate at a scale that is, frankly, just mind-boggling every single second of every day.
And that leaves us with one last, kind of fascinating thought to chew on. We've managed to build these incredibly complex, dynamic digital cities that are constantly in motion. So the big question for the future is, how much of this can we eventually automate away? Will we get to a point where these cities can build, heal, and manage themselves entirely? Kind of makes you wonder, right?